1,
Yeah.
2,
Okay.
3,
Sure.
4. It's
That's
my
fine.
chapter 4 check-in. Hope I can help you some more.
I hope so.
I have the questions and the answers too. I hope this helps. All right, hello. It's me, Mr. Barbera. Welcome to the chapter 4 practice test video. Let's get started. Okay, so standard 1. We're finding the scale factor. I went ahead and reminded you right here that the scale factor is found by taking the copy over the original. And remember, when we do that, we need to look at corresponding sides. So if I'm looking at a figure, I need to look at the side that's in the same location on the shape. So what is the scale factor from figure A to figure B? If I'm going from figure A to figure B, I'm going from this side to this side. So my original is figure A, and my copy is figure B. Doesn't matter which sides I pick. So I'm going to pick the 3 and the 6. So my copy is 3. And it's over my original, which is 6. And that actually simplifies to 1/2. And now I can look at this and say, okay, this answer makes sense because I started with a bigger figure and I went to a smaller figure. So my scale factor should be less than 1. Now, in part B, it says, what is the scale factor from figure B to figure A? So if I'm going from B to A, it's getting larger. And when we switch our fraction, because now my original is figure B, so it would be the copy now is figure A, so that'd be the 6, and the original is figure B, which would be the 3. It would be 6 over 3, which simplifies to 2. And that's all there is for standard 1. So anything like that, if you can remember it's copy over original, you should be able to find it. Even if it's a bad fraction or something, you can still just put copy, or a decimal, you can put copy over original, and that'll give you your scale factor. Standard 2. Standard 2, we're deciding if a relationship is proportional or not. So remember a couple things about a proportional relationship. If two variables are proportional to one another, as one changes, the other will change at a constant rate. That's your unit rate. So in this case, if we look here, it says Carmen is downloading music for her pod. Each song costs $1.85. Is the relationship between the number of songs purchased and the cost proportional? Well, first of all, as we talked about a lot in class, if you bought 0 songs, it would cost you $0. That's important for a proportional relationship. That has to be true. If I bought 1 song, or if Carmen buys 1 song, it would cost her $1.85. And if she buys 2 songs, it's just going to keep going up by $1.85. So actually, what's $1.85 times 2? That'd be $2.70. I hope I'm not making a mistake there. And this would continue to grow by $1.85 each time. So that is a proportional relationship. So is it proportional? Yes, it is proportional because each song she purchases will cost $1.85, and 0 songs would cost $0. I think that's a fair explanation there. Moving on to B, we'd show how we would find 5 songs. So I was actually showing that you could count up by $1.85. So that's one strategy. The other option is in a proportional relationship, we can take the unit rate, so the cost for 1 song, right here, $1.85, and multiply it by the number of songs we want, which is 5. Now I have to come over here and multiply that one. So $1.85 times 5. 5 times 5 is 25. 5 times 8 is 40, plus 2 would be 42. And 5 times 1 is 5, plus 4 is 9. And my decimal, there's 2 numbers behind the decimal point. So I put 2 numbers behind the decimal point from my solution. So I wrote that wrong, excuse me. $9.25. Part C. Now we had a little wrinkle in there. In addition to the songs purchased in parts A and B, Carmen purchases 2 symphonies. These are longer songs. Symphonies tend to be longer. They cost a little more online. And each of these costs $2.50. Is the relationship between the number of songs and the cost proportional now? Okay, quick little note here. If we were only buying the symphonies, each song would cost $2.50. So this would still be proportional. But since we said in addition to the songs purchased in parts A and B, now we've changed the price per song. It's not $1.85 anymore. So this is not proportional because each song doesn't cost the same amount. So no, each song does not cost the same. So the price does not increase by the same amount each time, or each song, I guess I could have written. There you go. Also remember that if you had an extra cost, like if I said there was a $5 membership fee to join the whatever website this is where we're downloading from, then that would not be proportional because that flat $5 fee makes it not proportional. All right, let's go on to standard 3. Standard 3. This one's split over the front and the back of the test, so sorry about that. On the front here, what is the constant of proportionality in the graph below? Remember, the constant of proportionality is another word for unit rate. And it's the number of whatever y is for one x. So if I look at when my x coordinate is 1, whatever my y is, that's my unit rate. Or if I'm thinking about it in terms of the word problem, whenever I have one of the independent variable, how much of the dependent variable do I have? So if we come down here, this one, you could see that 1 would actually be here. And you can't actually tell what this line is, but if we look, each line's going up by 50. So this would have to be 50 right here. So my constant of proportionality in this case would be 50. And actually, I should put the units. It'd be $50. Let's flip over to the back here. Oh, that's a little messy. Why don't we use another one so it's cleaner? On the back, you're being asked a similar question. But now we're finding the constant of proportionality in a table. So remember, just like I said, we're still looking for the unit rate or the constant of proportionality when x is 1. In this case, it's given to you in the table. When days is 1, the amount of money I pay is $6.50. So my constant of proportionality would be $6.50. Now, if I was not given this point, let's say I was only given this point right here, I could still find my unit rate by dividing 13 by 2. So if I took 13 and divided it by 2, that would give me 6.50, or 6.5, which is the same thing. Or I could divide 19 by 3. The key here is that the unit rate, or constant of proportionality k, is always equal to whatever the y is divided by the x. So 1950 divided by 3. 13 divided by 2. Or 650 divided by 1. Let's go to standard 4. All right, standard 4. Speaking of k equals y over x, we're looking at a proportional relationship here. And again, we're going to find the constant of proportionality, or the unit rate. And we just said you can do that by taking y and dividing by x. So I can take any point here in this table and divide the y by x. And just to prove that point, I'm going to do it a couple times. I would probably use these ones that have whole numbers here. So I'm looking at this one, and I'm looking at this one. The fractions are okay, but they just get a little messy. So if I took the y, 9, put it over 6, that's my unit rate. I can actually simplify that by dividing both of these by 3, and it becomes 3 over 2. Now, just for fun, let's look at this point here, 18 and 12. This would be 18 over 12. Well, if you notice, if I divide both of these by 6, this is also equal to 3 over 2. So I just wanted to show you that you can do the unit rate with any of these points. And if you did the same with 9 over 2 divided by 3, you would also get 3 over 2. Now the equation. All proportional equations are always in the form y equals kx. You will not change the y or the x. Those stay the same. Do not plug in a point for that. You just find your unit rate, and you're just going to plug it in for the k. So our unit rate was 3 over 2. That's my equation. Y equals 3 over 2 times x. And that's it. Let's go to standard 5. All right, standard 5, last but not least, combining like terms. Remember, like terms have the same variable, but they also have the same power. So if I have x squared, I cannot combine this with x. They have to have the same variable and the same power. So looking here at letter A, I look at my x's first. I have an x, and I have minus 2x. Make sure you look at the sign in front of the term. This is not a positive 2x. It's a minus 2x. So if I have 1x, I take away 2 x's. 1 minus 2 would be negative 1. And I can write negative 1x as just negative x. It's the same thing. Now, I have minus 3, and I'm adding 5. So I would make 3 0 pairs, and I would have 2 positives left over. So negative x plus 2. Moving over to B, we have an example of the distributive property. So we have 8 groups of x minus 2. We saw in class, and you might have remembered from 6th grade, that we can distribute the 8 to both terms. So 8 times x is 8x, and 8 times 4 is 32. But we are subtracting, so we're still subtracting here. Part C. Again, we're going to look for my x's. So 2x and minus 4x. 2 minus 4 would be negative 2x. And then negative 3 and plus negative 1. So I have 3 negatives. I add another negative. So that's going to be negative 4. So I can either write that as plus negative 4, or if you wanted to, you could write it as minus 4. Moving on to D. Another distributive property problem. So 6 times x is 6x. 6 times 10 is 60, and we're going to stay subtracting. So 6x minus 60. All right. Good luck studying for this. Please ask your teacher or come into math clinic if you need a little bit of review.